हेलो। सो कभी कभी एक सवाल आता है सम इन many cases students have asked me that if there is a spring with mass, then what will happen to the time period of the SHM of a block attached to that spring. If there is a spring, say spring constant K, and the mass of the spring is small m, and there is a block attached which is of mass capital M, what will be the time period of this system? Now, first I will tell you the answer and then we'll go for the proof. So, this spring, a spring with mass, is equivalent to a spring without mass. Say you have a massless spring, and the whole mass, the effective mass is 1/3 of the mass of the spring, which is concentrated at the end. That means the end which is moving, and there you have this mass capital M. And what will be the time period? As you know, if you have a system like this, say this, the block and 1/3 of the mass of the spring, and that is converted to a particle at the moving end. Okay, so now here what you have is the, so here the time period will be actually 2 pi root over of, so the mass will be m plus small m by 3 by k. So this will be the answer. Now, why this 1/3 mass of the spring is considered here? So now I'll prove it with this following diagram. Say there is a spring, and say this end of the spring is stretched. Say the length of the spring is L, and say this end of the spring is stretched by S. Okay, so that means the change in length is S. So change in length. So see, actually this is a fixed end, right? ये तो fixed end of spring का. And say if you consider this point at a distance x, then this point, this yellow dotted point will move forward by s into x divided by L. So s into x divided by L. Why? What is the reason behind it? Because see, very simply, if you see that from here to here, okay, there are how many coils? Say you consider this x is equal to half of the length of the spring. So यहाँ पे टोटल अगर n coil रहा, so n coil का there is an increase in separation between the successive coils. तो अगर हाफ लेंथ लिया ना तो हाफ होगा. सोचो कि यहाँ पे 100 कॉयल है, एक एक कॉयल का बीच में अपन इंक्रीज इन लेंथ होता है हाउ मच? इट इज़ एक्चुअली एस बाई 100 ना. ये जितना कॉयल रहेगा, सो गैप बिटवीन सक्सेसिव द क्लोज बाई कॉयल्स will increase by this s by 100. So if you take half the length, that means suppose if x is equal to L by 2, so then you have how many coils here? So there from this point to this point you have 50 coils, because this total length of the spring has 100 coils. At half this length you have 50 coils. तो यहाँ पे कितना होगा? 50 into s by 100. That means it is s by 2. So proportionately होगा ना. So if you consider the change in length ना, ये देख यहाँ पे change in length, यहाँ पे मतलब if you draw a graph like this, x versus the say that displacement of a point at a distance x from the fixed end, ये अगर total s होगा and ये total L है, so ऐसे ही होगा ना. So same way, if you find this end has a velocity v, so the velocity of this yellow dot point is how much? It is Vx by L. So now we will calculate the kinetic energy of the spring. We will calculate kinetic energy of the spring. ठीक है. So coming back to that, calculating kinetic energy of the spring. So this end has velocity v, and so this has length l, and at a distance x, this will have a speed vx by l. Okay, so now if I divide this into small lengths dx is each, so this is dx. So if you consider this one, ये है, इसका काइनेटिक एनर्जी क्या होगा इस पार्टिकल का? दिस पार्टिकल हैज़ काइनेटिक एनर्जी is equal to half, now half m by l times vx by l square, है ना, half m by l times vx by l square. So it is m v square by 2l cube times x square. ये है kinetic energy. So the kinetic energy of the spring, so this is kinetic energy of this dx length. Kinetic energy of the spring, you need to integrate it na, from say m v square by 2l cube, or we can, चलो ठीक है, that's a constant term, so x square dx from 0 to l. So what do you have here? See this mv square by 2l cube, that's a constant, so it is x cube by 3. X cube by 3, you have 1/3 into l cube. Okay, so that means you have half of m by 3 times v square. So half m by 3 times v square. So now you know it very well that having this whole spring of mass m is equivalent to having a massless spring and a point mass m by 3 at the moving end. Okay, so that's why this result follows.